Grade 12s, on our third day of trigonometry, we're going to be referring to that chart again, BLM 1-3, and we're going to continue to fill it out. So we're just going to do a quick recall here on the three angles of reference that we focused on last time. 30 degrees is an important angle, and we took the measurements for the ratios for that from short side being 1, 2 for the hypotenuse, and root 3. So any triangle in those ratios will have a 30 degree in it. So sine of 30 degrees, looking at opposite over hypotenuse, would be a half. Cos of 30 degrees, adjacent over hypotenuse, is root 3 over 2. And tangent of 30 degrees, opposite over adjacent, is 1 over root 3. We're going to be using these in the next slide, so I wanted to have them handy for us. 60 degrees, coming from the same set of numbers. Hypotenuse of 2, short side of 1, and medium side of root 3. Sorry, I wrote 30 degrees in there and I said 60. 60 degree triangle. So we got the three trig ratios for 60 degrees. And any triangle that has sides in that ratio, 1 to root 3 to 2, will have a 60 degree angle in it. And a 30 and a 90. There we go. Sine 60 degrees, opposite over hypotenuse, would be root 3 over 2. Cos of 60, adjacent over hypotenuse, is 1 over 2. And tan, opposite over adjacent, is root 3 over 1. The last special triangle that we looked at is a 45 degree triangle, where proportionally the sides would be 1, 1, root 2. So sine of 45 degrees is opposite over hypotenuse, which would be 1 over root 2. Cos of 45 degrees is adjacent over hypotenuse, which is also 1 over root 2. And lastly, tan of 45 degrees, opposite over adjacent, is 1 over 1, or 1. So you need to have those recorded on that sheet, and we're going to refer back to these for some of our subsequent slides. To develop the trig ratios of values larger than 90, we're going to put them on the Cartesian plane. So we're going to start with what we know, and then extrapolate beyond that. So an angle in standard position, so we're going to throw some new terms at you, has its initial arm on the positive x-axis. So our initial arm is where we start, and it lies along the x-axis pointed in the positive direction, and it is lying at the vertex at 0, 0, at the origin. That is our initial arm. And we are going to rotate that initial arm. We're going to start with a 30 degree rotation. And so our terminal arm happens after we rotate counterclockwise and stop there. So we rotate counterclockwise by tradition. And in that, I have a 30 degree angle in there, but that is our angle of rotation. So for this particular rotation of 30 degrees, I'm just going to set up some points that I know. So if I have rotated 30 degrees, I will pass through the point root 3, 1. And the reason I know this is that I know a 30 degree triangle will look like 1 across from it, root 3 adjacent to it, and a length of 2. So I can see my x value, or horizontal, for a little triangle that I've just dropped there, as root 3, and a vertical of 1 it will pass through the point root 3, 1. And that distance of the origin to that point is 2, because I know that about a 30-degree angle. So that terminal arm will pass through a lot of other points, but I know it will pass through root 3, 1. That length of 2 we refer to as r. R is the distance from origin to a point on terminal arm. We often refer to our angle of rotation as theta. Of course, we're really stuck on that term. And we're going to write our sine, cos, and tan of our angle of rotation. In this particular case, it is 30 degrees. So our sine of 30 degrees, cos of 30 degrees, and tan of 30 degrees. We know these already. So we're going to write them in from what we know and then extrapolate. Our sine of 30 degrees is 1 over 2. And we can see on this particular diagram that 1 is my y value and 2 is the r value, or the distance from the origin to the point. So I have y over r. Cos of 30 degrees, the ratio that I know, is root 3 over 2, which for this point is the x value, and 2 is that length value. Tan of 30 degrees from my chart is 1 over root 3, which is the y value over the x value. For angles of rotation in standard position that pass through a point, x, y, the sine of the angle is y over r, cos of the angle is x over r, and tan of the angle is y over x. Let's look at an angle of rotation of 60 degrees for a moment. So I have my initial arm, and I rotated it counterclockwise, and I stopped here, my terminal arm. I know a point that that terminal arm will pass through because I know what a 60-degree triangle can look like. The one that we did as a model, I'm just creating a right angle triangle here, had lengths, adjacent length of 1, opposite length of 3, and the distance from the origin to this point that I know is 2. So looking at horizontal and vertical as xy coordinates, it would go through the point 1 root 3. So sine of 60 degrees, we said on the last slide, was y over r, is root 3 over 2. Is it true that the sine of 60 degrees is root 3 over 2? Yes, if you look at your chart, it is. Cos of 60 degrees is x over r. Let's look at our point. X value in the point is 1, and the r value is 2. And lastly, tan of 60 degrees is y over x, which is my y value from that point is root 3, and the x value is 1. Now we're going to look at some angles that we don't know. 210 degrees. So first thing I need to do is draw a diagram. Find the primary trig ratios for 210 degrees. So an angle of rotation of 210 degrees. I start here, my initial arm. I'm going to rotate counterclockwise 210 degrees. So I've passed 90, past 180, 210 degrees. So my terminal arm will be there. I know that 180 degrees plus 30 degrees is 210 degrees. Well, I know lots of things about 30-degree triangles from our special angles. So I'm going to drop a triangle in there that I know lengths for. So 30-degree triangle could certainly be opposite ratio of 1 to 2 to root 3. So this terminal arm will definitely pass through the point 3 to the left, negative root 3, 1 down, negative 1. So it will definitely pass through that point. So I can write my primary trig ratios using y over r, x over r, and y over x. Sine of 210 is y over r. My y value, because the terminal arm is downwards, is negative 1. My r value is 2. So the sine of 210 degrees is negative a half. The cos of 210 degrees, which is x over r, is negative root 3 over 2. Notice that r is always positive. R is the length of 0, 0 to the point, and that length is always positive. Tan of 210 specifically, is y over x. Y value is negative 1. The x value is negative root 3. So it would be a positive 1 over root 3 for tan of 210. Tan is the only one that's positive in this quadrant. Let's look at 135 degrees. 135 degrees, the first thing I want to do is draw a diagram. My initial arm is there. I am going to rotate to a terminal arm that's 135 degrees. So I'm rotating 90 and another 45 degrees, and I have my terminal arm. Angle of rotation of theta. So I want to know a point that that terminal arm will pass through. Well, I could find one because I know that there are 45 degrees left in here between the 135 and 180. So I'm going to create this little triangle of special angles that I know. 45-degree triangle, it could certainly be in the ratio 1, 1, root 2, where there's a point right there that's root 2 away from the origin, that's 1 to the left and 1 up. So this point would have the values 1 to the left, 1 upwards of negative 1, 1. So my terminal arm will pass through the point negative 1, 1. Sine of 135 is y over r, which is 1 over root 2, which is positive. Cos of 135 is x over r. My x value is negative 1, and the r is always positive root 2. Tan of 135 degrees is y over x, which is 1 over negative 1, or negative 1. These values of sine, cos, and tan of 135 degrees can also be put on your sheet. We can refer to those. 210 can also go onto your sheet. We've already got 60. Okay. Let's add to the pile the 3 primary trig ratios for 300 degrees. So I have an angle of rotation of 300 degrees. We have an initial arm here. Angle of rotation is going to be counterclockwise, 180, 270, 300. So my terminal arm will be here. My terminal arm, oops, let's put our theta on there. Our angle of rotation is 300 degrees. I want to know sine 300, cos 300, tan 300. And I am looking for y over r, x over r, and y over x. To find a point that that rotates through, I am going to use what I know, that this is 60 degrees. And I can draw a triangle because I know a 60-degree triangle from yesterday. 60 degrees would be in the ratio of adjacent side being a 1, opposite side being root 3, and a length of 2 to that point. That point, therefore, is 1 to the right, root 3 down. So the terminal arm for a 300-degree rotation will pass through the point 1 minus root 3. So our ratios will be y over r minus root 3 over 2. X over r would be positive 1 over root 2. And y over x would be negative root 3 over 1. Those are the three trig ratios for 300 degrees. You can add those to your chart as well and fill in the other ones. I would like to do one of your homework questions with you, number 11. We didn't do a word problem, so I would like to just do this quickly. A 3-meter long brace is placed against a wall. Okay, so we've got the floor, and we've got the wall, and we've got a very crooked wall, and we have a 3-meter brace. So that the bottom of the brace makes an angle of 60 degrees with the ground. And we're going to assume that wall is actually straight to the ground. We want to draw a diagram to represent this situation. Done. Part B says how far up the wall is the top of the brace. I want to know that measurement. So I want to know opposite and hypotenuse I have as 3 meters. So we are going to use exact trig ratios. So I know that sine of 60 degrees is the one that I want to use because I want opposite and I have hypotenuse. So sine of 60 degrees is x over 3. And we can use decimals on our calculator, but we would like you to do it exactly for this exercise. And we know what the sine of 60 degrees is. It's root 3 over 2. So if you could use your charts for these word problems, you will come up with exact answers. X is exactly equal to 3 root 3 over 2.